Hello everyone. Through this video, we are going to discuss about the introductory part, the preliminary informations regarding the first exercise in the chapter of real numbers. So here goes the heading, real numbers. We are starting with introduction and preliminary informations before starting the first exercise 1.1. The first point that we are going to discuss here is real numbers. So, what are real numbers? In very simple words, the collection of all rational and irrational numbers can be considered as real numbers. That means, suppose this is the world of real numbers. This entire world of real numbers can be divided into two parts. One for rational numbers and other one for irrational numbers. Now here there are some examples. Say 1, -1, 1 by 7, 7 by 8, and 0, root 2, root 3. All these belong to this category of real numbers. Now, by the term rational numbers, what do we understand? Rational numbers are those numbers which can be expressed in the form p by q with q not equal to 0. In this category, numbers like 3 by 7, then 8 by 13, then any fraction belong to this category in which the denominator is not equal to 0. Now, when there is a question of integers, do these integers belong to this category of rational numbers? Let us check. Suppose an integer 2 we are considering. So 2 can be expressed in the form 2 by 1. Yes or no? Here 1 is taking the place of q while 2 is taking the place of p. So in this case we get that q is not equal to 0. Ultimately we are expressing 2 in the form p by q with q not equal to 0. So what does it mean? All the integers belong to this category of rational numbers. After that, which numbers can be considered as irrational numbers? The numbers which cannot be expressed in the form p by q, q not equal to 0, are known as irrational numbers. So square root of any prime number, say p be any prime number. So here, that is why in this case we had considered these numbers. 1, it is already an integer, a positive integer. Then -1, this is a negative integer. Both these can be expressed in the form p by q with q not equal to 0. Similarly, 1 by 7 is a fraction which can further be expressed in the form p by q. Similarly, 7 by 8, it is again a rational number as it can be expressed in the form p by q. What conclusion we draw for 0? That is important. Let us check here. For 0, we can express 0 in the form 0 is equal to 0 by any number. If 0 is divided by any non-zero number, in that case, we can express this in the form p by q, where in place of 0 we can put p and in place of 5 we can consider q, where q is not equal to 0. So ultimately 0 is an integer and that is why this is a rational number. After that, root 2, root 3, these two are square roots of prime numbers. Therefore, these two numbers can be considered in the category of rational numbers which cannot be expressed in the form p by q with q not equal to 0. So, the next concept that we are going to discuss here is divisibility. What is divisibility? Let us check what is written here. A non-zero integer b is said to divide an integer a if there exist integers q and r such that a is equal to pq plus r. In this case, we are going to divide the integer a by the integer b. That is why a will be considered as the dividend. Then the number by what we are going to divide a will be considered as the divisor. So b is called the divisor here. After that, two more integers we have to consider, that is q and r. So in this case, q is considered as the quotient and r is considered as the remainder. In the previous classes, we already got the division algorithm as dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. So this is known as the division algorithm. So divisibility, the term divisibility refers to this concept of division algorithm where we find dividend is equal to divisor into quotient plus remainder. So here this can be understood with the help of an example. This is the example set here. We are considering two positive integers 9 and 4. When 9 is divided by 4, then by concept of divisibility we get what? 9 is equal to 4 into 2 plus 1. That means when you divide the number 9 by 4, in the quotient part you get 2 because 4 2 ja 8. And when performing subtraction we get here 1. So 9 becomes the dividend, then 4 becomes the divisor, then 2 becomes the quotient here and 1 becomes the remainder. So when we put it in the form of division algorithm, in the format dividend is equal to divisor into quotient plus remainder, we get what? 9 is equal to 4 into 2 plus 1. So that's all about divisibility. The next thing that we need to know is Euclid's division lemma. So before getting into the concept of Euclid's division lemma, we need to know what is called lemma. What does it mean? So here is a note here. Lemma is what? A lemma is a proven statement used for proving another statement. That means lemma is a statement, a previously existing, previously proven statement which can be further used for proving another statement. That means suppose we are already having a statement which is already being proved. That particular statement we are going to use for proving another statement. Let us check how can we do it. So the formal statement of Euclid's division lemma is nothing but the restatement of division algorithm. Just now we have learned what is division algorithm. Division algorithm is nothing but the concept, the format dividend is equal to divisor into quotient plus remainder. So for the given positive integers, let two positive integers a and b be given to us. Then there exist unique integers q and r such that, and one more thing we need to consider here, that is what? A is greater than b. When a is greater than b, of course we can divide a by b. That means a becomes the dividend, b becomes the divisor. So there exist unit integers q and r such that a is equal to pq plus r, where a is the dividend, b is the divisor, q is the quotient and r is the remainder. This is nothing but the restatement of division algorithm. But one condition is to be followed here, that is what? The remainder is either greater than or equal to 0. But it must always be less than b. Once again, we are going to consider the previous example. The previous example was what? We considered two integers 9 and 4. Say we are going to divide 9 by 4. When we divide 9 by 4, we are getting the quotient to be 2 here. And in this part we can write 8 because 4 2s are 8. And on subtraction we shall be getting the remainder as 1 here. Now, when we follow division algorithm, we can write what? 9 is equal to 4 into 2 plus 1. So, after this, the remainder is 1. It is of course less than 4. If suppose this remainder is equal to 4, if suppose I am getting 4 here, once again it is divisible. Actually, this division method will not be correct. If we find any number that is either equal to 4 or greater than 4 as the remainder, our division rule is not correct. That is why it must be, the remainder must be less than the divisor. Then only the method of division will be correct. And either suppose in a particular division we must have to get the remainder as either 0 or non-zero. A 0 remainder or a non-zero remainder which must be less than the divisor. So this is the condition to be followed here in Euclid's division lemma. Next, here goes the heading, Euclid's division algorithm. So in this particular context, we have to know three things. What is algorithm? Actually, the term algorithm is used here. What does the term algorithm mean? How does this algorithm works? That means working rule of Euclid's division algorithm. Then after, every concept in mathematics has a practical utility. Why do we have to use, in what context do we have to use Euclid's division algorithm? That is an important part of this particular concept, and that is why we need to know what is its utility. So these three things we have to learn for getting into the concept of the Euclid's division algorithm. First thing is what? Meaning of algorithm. Then after, working rule. How does Euclid's division algorithm work? And then after, utility of Euclid's division algorithm. Now let us check what does the term algorithm mean. So it is actually a series of well-defined steps required for solving problem in mathematics. Suppose in different exercises of the textbook of mathematics, we often get lots of questions, lots of problems. There are different methods for solving each and every problem. Now, how to proceed with the solution of a particular problem in mathematics? There are systematic number of steps. Often we get systematic number of steps while solving all the questions, all the problems in mathematics. These steps can be considered as algorithm. That is why it is said that the definition of algorithm is what? It is a series of well-defined, means what steps we are following, each and every step should be existing and should have individual importance. It is a series of well-defined steps required for solving problems in mathematics. So here in this case, for solving a particular set of problems in the first exercise in the chapter of real numbers, we have to follow some well-defined distinct steps, and these steps comes under Euclid's division algorithm, and that is what algorithm refers. The next important thing, as I have shown you, that we have to know is working rule of Euclid's division algorithm. So let us check step 1. In step 1, since algorithm is nothing but some well-defined steps for solving certain questions in mathematics. So step 1 is what? To apply Euclid's division lemma. Lemma was what? Restatement of restatement of division algorithm. So we have to apply Euclid's division lemma to two non-zero positive integers a and b, where two integers q and r will exist such that a is equal to bq plus r. That means actually two positive integers a and b will be given to us. Some numbers will be given to us where a will be greater than b. We have to choose the bigger number and a smaller one. For these two numbers we shall be getting two more integers so that we can make themselves, we can arrange themselves in this format. So while dividing the bigger number by the smaller one, we must be getting some quotient and some remainder in step 1, where the remainder will be either 0 or will be greater than 0. But we must have to notice one thing, that it has to be less than the divisor. So step 2 is what? When we get a 0 remainder, that means when the remainder is 0, of course the divisor will be acting as the HCF of A and B. That means the two numbers we are considering A and B, where A is bigger than B. So the bigger number will be taking the place of dividend, while the smaller number will be taking the place of divisor. So after performing division, if suppose we get the remainder as a 0 remainder, in place of remainder, suppose nothing is left, that is why we shall be putting 0 here. If suppose in the first step itself we are getting the remainder to be 0, we must have to understand that the divisor here, b, whatever number we are putting in place of b, that will be acting as the HCF of both a and b. That is the case when r is equal to 0, when remainder is equal to 0. Suppose in this first step we are not getting, if we look at this second point, suppose in this first step the remainder is not coming as a 0 remainder, and we got some non-zero quantity here in place of remainder. In that case we have to apply the same procedure, means whatever step we had followed in the first step, step 1, the same procedure we have to carry on with two numbers in second step. Which two numbers? Divisor of first step and remainder of the first step only. That means in this step, divisor of the first step will be taking the place of the dividend, while the non-zero remainder will be taking the place of the divisor. Into something we shall get plus, in place of remainder there will be something else. In this step also, if suppose we do not get a non-zero remainder, in that case the same thing we have to repeat in the third step also. That means in that place again this term will be taking the place of, this term will be taking the place of the dividend. After that this term will be taking the place of the divisor. Into quotient will come later on, then again remainder. And if we get 0 here in place of this remainder, in that case this will be acting as the HCF of these two numbers. And if we do not get 0, then we have to continue again with these two numbers. Now let us look at the utility of Euclid's division algorithm. The prime utility of Euclid's division algorithm is to find out the HCF of two non-zero positive integers. The only utility of Euclid's division algorithm is to find out HCF of two non-zero positive integers, which I have explained just in the previous slide. Now, Euclid's division algorithm, let us explain with the help of an example. Suppose two positive integers are given to us, say 10 and 16, out of which 16 is bigger than 10. So let us proceed with step 1. We can divide 16 by 10. So following Euclid's division algorithm, in the first step actually we are trying to find out HCF of 10 and 16. So the first step to be followed here is what? The bigger number will be taking the place of dividend. That means 16 will come first. That is equal to divisor is 10, because I am going to divide 16 by 10. When I divide 16 by 10, let us check what result we get. 10 into 1 is equal to 10 here. The remainder comes as 6. So here I can write 16 is equal to 10 into 1, that means divisor into quotient, plus remainder is 6. As we had already discussed, 6 is a non-zero remainder. Therefore, we have to repeat step 2. So in step 2, 10 will be taking the place of dividend. That means 10 will come forward, which will be followed by equal sign, and then this non-zero remainder will be taking the place of divisor. So in this case, I'm going to divide 10 by 6. Let us check what we get. When 10 is divided by 6, I get here 6 1 just 6, remainder is 4. So I can write here 6 into 1, that means divisor into quotient, plus remainder is 4. Again I get a non-zero remainder here. So the process I have to continue. So in the next step, this term will be taking the place of dividend. 6 will become the dividend. That is equal to, this non-zero remainder will come as the divisor. So 4 will be placed here. Now when I divide 6 by 4, I get 4 1 ja 4, 2 is the remainder. So I can put 6 is equal to 4 into 1, 4 into 1 plus remainder is 2. Again I got a non-zero remainder. That is why the same procedure I have to continue. 4 will be taking this place. 4 is equal to, this non-zero remainder will be taking the place of divisor. And when I divide 4 by 2, I get 2 as the quotient plus remainder as 0. Since this is the step where I got 0 remainder, therefore the divisor of this step will be acting as the HCF of these two given numbers. So in this case, HCF is equal to 2. And that is how we can find out HCF of two numbers by using Euclid's division algorithm. So that's all about the preliminary informations regarding the first exercise in the chapter of real numbers. Before starting the first exercise, exercise 1.1 of the chapter of real numbers, we must have to understand these preliminary informations. In the next video, I'm going to solve a few questions of the first exercise of the chapter of real numbers. Thank you.